All right, let's talk about 8.4.2, which is confidence intervals for proportions. I'm going to go over that homework 8.4.2, which has 3 objectives, one of them being to calculate the sample size required to estimate the population proportion. The other one is to find the margin of error given some information. And then the third one is to find the confidence interval for a given situation. So I have my homework in here and I have RGuroo open and I have my calculator here so I can kind of type the formulas in here for you. So let's just start with this problem. It says, suppose an automotive repair company wants to determine the current percentage of customers who keep up with regular vehicle maintenance. How many customers should the company survey in order to be 95% confident that the estimated sample proportion is within 5 percentage points of the true population proportion of customers who keep up with regular vehicle maintenance? So, translating this a little bit, we want to find the sample size. We want to find how many customers we should, or the company should survey. So that's your N. So we are trying to find N. So here, not capital N. We are trying to find N. We don't know that. The other thing that we know is we know that we have a confidence level of 95%. So that's our the confidence that we want to use to create the confidence interval, and then the margin of error. So it's telling us that we want to be within 5 percentage points of the true population. So remember that the margin of error is that distance that we are allowing ourselves to go from the center of the confidence interval. In this case, the center of the confidence interval is given by the proportion. So we want to go 5, we are going to allow ourselves to go 5 percentage points to the left and 5 percentage points to the right. So because it's percentage points, we need to change that percentage to a decimal. So that is the information we have. We want to find the sample size. We have a confidence level of 95%, and we have a margin of error of 0.05. So now, to find the sample size, the formula is, we need to find the critical value and square that. We need to multiply that times P. I'm going to put the estimate because we want the proportion from the sample. And then we have 1 minus P. And we are going to divide all this over the margin of error squared. All right, so that's the formula we need for the to find the sample size. All right, and ignore all the errors in here. I know that I cannot type, but it's the easiest way for me to talk and explain and do the math and everything at the same time. Okay, so then the first thing that we need to figure out is who is this critical value, right? The critical value is given in this table. So all of these numbers are critical values. So which one is the one that we need depends on the alpha. So here, alpha is the same as 100 minus our confidence level. So then this will be 100 minus 95, which is 5, all right? So that it's alpha. Now we need to find alpha over 2. So alpha over 2 is that 5, 2 is that 5 over 2, which is a 2.5. So then it means that that C score or that Z value of alpha over 2 is 2.5. And again, we use the decimal, right? So this is the Z that we're finding is the finding of alpha over 2. Alpha over 2 is 2.5. And so again, if you need to see this in the other way. So that's what we have. So the Z of alpha over 2 is the Z of 0.025, because this is what we found for alpha over 2. And so we go here and we find that Z of 0.025, and this 1.96 is our critical point. Okay, so we have the critical value. For these problems that we need to find the sample size, we always assume P. We always assume P to be 0.5. It's like a 50-50 chance. So there is a 50-50 chance of our outcome to be a success or a failure in our problem. So we just assume P is 0.5. So then 1 minus P, it's also 0.5. because we are subtracting. All right. And so once we have that, we need to go back to this formula. So I'm going to copy and paste it here. And I'm going to take this out because I'm going to start replacing here. So the critical value is 1.96. The P hat is 0.50. The 1 minus pi, the 1 minus P hat or estimate is also 1.50. And our margin of error we said was 0.05. So I'm going to go here, 0.05. And then this give me that sample size. All right. So for the sample size, if we get 384.16, so this is telling me that I need to survive 384 people per person, and then 0.60 of an additional person. So I cannot go and survey 0.16 of a person, right? I need to count one more person. So then we're going to round this to 385. So then we go here. Our sample size should be 385. And we found our sample size. All right. So again, the formula for that is sample size. It's equal to the critical value squared times the proportion from the sample times 1 minus the proportion from the sample divided by the margin of error squared. We had all of the information. Margin of error is 0.05. We have an alpha of 5%, meaning that half of that is 0.025. We go to the table. Our critical value is 1.960, this number here. P, it's going to be assumed to be 0.50 if we don't have more information. We don't have a sample size, and that's what we use to determine P. P is the number of success over the sample size. So we cannot find that proportion because we do not have the sample size. That's what we're looking for. And so then we put everything into the formula. Critical value, P, 1 minus P, margin of error, and we get 384.16, which we round to 385. Right, it's the same thing that we have in here. This Q in here is 1 minus P. So when you look at the Q hat, then Q is 1 minus 0.5. And I'm sorry for the notation. I cannot do the hat in here. So I'll do it's the same thing. So I'm just referring to the proportion that is coming from the sample. And all right. So next is calculate the margin of error. So then it says, suppose 420 randomly selected people are surveyed to determine whether or not they subscribe to cable TV. Of the 420 surveyed, 278 responded subscribing to cable TV. We need to find the margin of error for the confidence interval for the population proportion with a 95% confidence interval. So then we're going to do the same. Let's see, what information do we have? Right. So we have a sample size of 420. That's the amount of people that we survey. We have a number of success being equal to 278. This is the number of people that says yes, that they are subscribed to cable TV. When we find p hat, right, that proportion from the sample, the proportion from the sample is going to be the number of success over the sample size. Let me see if I can just do the whole thing. The number of success over the sample size. So P estimate is going to be 278 over 420. And again, I am going to take this out so that it calculates this for me. So the proportion, it's 0.66. All right. And so then if I need to find 1 minus P, then I do 1 minus that 0.66. And so the Q is going to be 0.34. To find the margin of error, the formula for the margin of error is the critical point, or the critical value, just to be consistent, times the square root of E times 1 minus B over N. All right, so there's your formula for the margin of error. So we need to find a critical point. So we have P estimate, and here is another estimate. So P estimate is 0.66, 1 minus P estimate is 0.34, N is our sample size, which is 420. So we have everything but the critical point. So again, for the critical point, we need to find who's alpha. Alpha, it's always 100 minus your confidence level. So again, it's 100 minus 95%, 95, and that is a 5%. So then when we find alpha over 2, we get, again, this 5 over 2, which is a 2.5. And so when I find that alpha, that z-score of alpha over 2, I have that z of 0.025, change it that percentage to a decimal. Remember that we're talking about a 95%, so 100%, if this makes it easier. Okay, it doesn't let me. So 100%, 95%, it's 5%. So I cannot use the percent. So I'm going to use the decimal. So we go back here and we check our table, and the z-score for 0.025 is 1.96. All right. So then now let's just move this down here, and I'm going to replace everything. So the critical value is 1.96. So P, it's 0.66. The 1 minus P is 0.34. And the sample size is 420. All right, so for this to calculate our value, we need to remove all this. So I remove it, and I get a margin of error of 0.045304565. We need to round to 3 decimal places. So I'm going to get this to 3 decimal places. The next one is a 3. So we don't need to round up. It stays the same. And we click submit. All right. And so again, formula is the same one. So you have to work the same thing that I did in the calculator. All right. Another one for sample size. So again, we don't have a sample size already, so we cannot calculate P. So the P that we are going to use is 0.5. So this is what we need again. So I'm going to copy and paste that down here to have it closer to us. So let's talk about the critical value. So critical value first. So we are trying to find, we are trying to find the sample size for a 92% confidence interval within 4 percentage points. Okay, so we need sample size, we need N. So N is critical value square times P times 1 minus P over the margin of error square. So let's talk about that critical point, because the critical point depends upon the alpha. So alpha is 100 minus the confidence level, which in this case is 92, right? So 100 minus 92 is going to be 8%, right? So then when we do the alpha over 2, we do the 8 over 2, which is 4. So again, remember this is a 4%. So when we write this, the alpha over 2 equals to the C score of 0.04%. So we go back to the table, we find that Z equals 0.04, and this 1.751 is our critical point, 1.751. Okay, so we don't need, or the only thing that we need is the margin of error. It's within 4%. So again, remember that we need to change that percentage to a decimal. So then I'm going to copy and paste this again. And I'm going to fill this out. So critical value is 1.751. 1.751. P is going to be 0.50. And the difference is going to be 0.52. Remember, this is always the case when we are trying to find the sample size, because there is no way for us to compute the population proportion or the sample proportion because we don't have a sample still. And this in here is a 0.04 because we want to be within 4 percentage points. So then we have that. And so again, what we said, we need to round this to the next whole number, because if we survey 479 people, we won't get the margin of error that we want. It's going to be smaller. So we need to go one more person to achieve the margin of error that we want. So then our answer should be 480. All right. So let's see what we get next. Okay, so this is what I wanted. So this is the third objective in here. We want to construct the confidence interval. So Emilia wants to estimate the percentage of people who have a financial advisor. He's going to survey 350 individuals and finds that 76 have a financial advisor. We need to identify the values needed to calculate a confidence interval at the 99% confidence interval, then find the confidence interval. So let's go here and find our proportion. So if we go to the calculator, the proportion, it's going to be the number of success, which is the 76 people that he found having a financial advisor, divided by the total number of people that he interviewed, which is 350. So then We need to round answers to 3 decimal places. So then P, it's going to be 0.217. So I'm just going to be adding this 0.217. All right. This in here. So when we go back to the margin of error, let me just copy and paste this. Right. The margin of error we know is the critical value times this in here. So the critical value is going to be this Z alpha over 2. And this in here is the standard deviation for the sampling of proportions, right? So then what we are trying to find here is this. So this is, let me see if it recognized it. Doesn't. I don't know if somewhere I have a Greek capacitor. I don't think I have it. All right, it recognizes the alpha, but not the sigma, but anyway. All right, so sigma is this little guy in here. That P estimate is equal to this formula. So we need to find who the rest of this is. So I'm going to hit it, and then I am going to find who this is. So again, we need P, which is 0.217 times 1 minus that same number. And that over the sample size, which is 350. So the standard deviation here is 0.022. Okay. The critical value, again, alpha is 100 minus confidence level, which is 99. So I only have a 1% left. So then when we do alpha over 2, we have 1 divided 2, which is 8.5. So then when we rewrite this of alpha over 2, it's the same as C of, remember that 0.5 is a percent. So we need to move this 2 points to the left. So we'll have 2 zeros. And so we are talking about this Z in here for a 0.5%. Remember, this is 10%, this is 5%, this is 2.5%, this is 1%, this is 0.5%. So the critical point that we are looking for is this 2.576. So that's the value that goes here. And so now with this, we need to find the confidence interval. Okay, so to find the confidence interval, you do the confidence interval is going to be equal to your estimate plus minus. We need to do plus and minus to go to the right and to the left. The margin of error, all right? And so we know who's the margin of error. And we know how to calculate the margin of error, and we know what is P, so we just need to calculate that. Instead of doing it by hand, though, I am going to go and I'm going to use RGuroo. So to find the confidence interval for proportions using RGuroo, you go to analytics, you go to analysis, you go to proportion inference, and you choose one variable. And then you have this. We don't have a data set. What we have is information about the sample. So sample size is 350. Number of success is 76. And if you click, you will see the same proportion that we found before. The 0.217 is just right there. we want to find, so here when it says, where it says confidence interval, I'm going to change this to 0.99. And we are going to choose the large sample Z for our method. All right. So now something very, I don't know, we need to be careful with is that it won't let you go through if you don't label your factors. So then don't overthink it. I would just put X, Y, and Z so that it let me go through. Because at the end, what you truly need is your lower and upper numbers for the confidence interval. You don't need like anything else. Okay, so then 3 decimal places again. So this is going to be 0.160 for the lower. And then the upper is going to be 0.274 because I need to round up. All right. And so if I submit in here, all right, so be very careful because if you get one of them incorrect, everything is going to be, it's going to mark you incorrect, even if what you have incorrect is just one thing. All right, and so again, the explanation, the confidence interval for the proportion is always built in this way: point estimate minus the margin of error, point estimate plus the margin of error, which is what I kind of try to say in here. We have point estimate, which is the P estimate here, minus the margin of error, and the estimate plus the margin of error. This is our critical point. So if I go back, here, this is the margin of error is the critical value, which is the Z. And then the square root, which is your standard deviation, okay? And you can see it here, the standard deviation, the sigma P is the square root of P times 1 minus P over N, all right? Which is exactly the same thing that we did. All right, so that's it. Let me see if I get another one of these. All right, interpretation. What does this mean? So we found a 99% confidence. We found that the limits were from 0.16 to 0.274. So which of the three is correct? So here is what the language is. We are estimating with a 99% confidence that, not the sample, because we know what the proportion on the sample is. We're 100% sure that the proportion for the sample was, what was it? Was 0.21, 0.22. So, okay, so we are not making inference about the sample because we do know information about the sample. We have the sample, all right? Second one, it says we estimate with 99% confidence that the true population proportion of people who have a financial advisor is between 0.160 and 0.274. This is what we are estimating. We are estimating with some confidence what is the value of the true population proportion, because we don't have information about the population, right? We do have information about a sample, and we are using that to estimate the proportion for the population. What we can say, the only thing we can say is that we can estimate with a 99% confidence, because that's the confidence that we are using up here. This is what we use to determine our critical value, that the true population proportion is between the two values that we found. It's between 0.16 and 0.27. That's all. That's all we can say about what we have. Okay, so let's try to do another one. So I am going to move on because I want one of those where we need to find the oh my God, the confidence interval, right? I don't want to find margins of errors anymore. I want to move on. I don't want to find sample sizes anymore. Okay, this is another one. Sorry, I am kind of chilling my way through, but I want one of this, right? So this is what I wanted. Okay, so let's see. It says, suppose 420 randomly selected people are surveyed to determine whether or not they subscribe to cable TV. Of the 420, 255 reported subscribing to cable TV. So then, now, who's P? So let's go to the calculator and find who is P. So then P is going to be the 255 successes over the 420 total that I surveyed. So P, again, 3 decimal places, is 607. All right, the number of people that subscribe to cable TV over the total amount of people that were in the survey. Remember that your standard deviation is this again in here. All right, so let me see if it allows me to do this. It doesn't like the writing. So then we cannot do that. So then this is going to be our value for P, which is 607, and then 1 minus the same thing over the N, which is 420, which is your total sample size. So that is your standard deviation. So rounded to 3 decimal places, that is going to be 0.024 because I round up. All right, so the Z, let's just see if we can do the Z easier here. We have a 90% confidence interval. So we do 100 minus 90. So if you do 1 minus 0.90, then you get the 0.1. And then you do the 0.1 divided 2, and you get the 0.05 that we are looking for. Right, which is a 5%. So 100, if we do what we were doing, 100 minus 90 is 10, and we divide 10, and when we divide 10 over 2, we get 5%. All right, and so 5% written in decimal form is 0.05. So then we need to come here and find that 0.05. So the critical point is going to be 1.645. And then again, to find the confidence interval, we are going to analytics, analysis, proportion, inference, 1 population. And again, I'm going to do X, Y, and C in here because otherwise it won't let me move. I surveyed for 120 total, and I got 255 successes. And that is a 0.607 proportion, which is the same that I got. We are doing a 90% confidence interval, so we change here in our method. It's a large sample Z. We click in here, and here is our lower bound. So 3 decimal places, and I need to round up to 8 because of the 9, and 3 decimal places, 6, 4, 6, and a 3, so I don't need to round, so that should be it. All right, so again, proportion of success over sample size. This is the standard deviation, which is the square root of P times 1 minus P over N. The Z is the one that you find in this little table with the confidence level. And then we use RGuroo to find our confidence interval. All right. So I hope this is helpful. And if you need extra help, please do not hesitate on reaching out to me.